which one of these, the -1 or the 1 plus 2i, has a complex conjugate? The 1 plus 2i, right? So what's its conjugate? 1 minus 2i. These are conjugate pairs. How many zeros is that now? 3. I need to figure out a way to get one more. Obviously, it has something to do with this one, and I'm just going to change that sign as well. Good or bad? Bad, right? That's not right. We only are taking conjugates for complex numbers, the ones with the i's in there. If I need a fourth zero, and I know that this is x is -1, what can I use that to do? A double root. That's exactly right. So a double root means it's just exactly the same. That didn't work. So this is a double root. So you want to be able to recognize either of those situations in a problem, okay? So that was the first step. Figure out the zeros. That's 4 zeros now, degree 4. That's good. Now we want to write factored form. What factors do I get from x equals -1? What factors? X plus 1. And how many do I need? 2, because it's a double root. Bless you. But I kind of want to review something with you before writing factors from these, okay? The reason why it's x plus 1 is more than, oh, it's just insider's lie, or you just take the opposite sign. Here's the actual reason behind it. I'm going to do this in a different color so you know I'm sort of like going off on a tangent a little bit. If I told you that x equals 3 was a 0, you would find the factor by doing x minus 3, right? We're all good with that. That's a positive number, okay? If I told you x was -1, we would still do x minus whatever the 0 is, right? But in this case, it's a -1. What is minus a negative? A positive. That is what's happening, why it's actually x plus 1. Okay, it's more than just, oh, we're just going to take the opposite sign. Here's how we use that information to write a factor using these funky things. It's x minus the 0, x minus the 0, x minus the 0, but what does the 0 happen to be? One plus 2i. That was supposed to be a bouncing ball. You're supposed to be following it and saying it. I'm sure that was lost in translation. And then for the last factor, it's still x minus the 0. And the 0 is 1 minus 2i. All right? It's kind of weird, but we shall persevere. So the next step is to do what with all those things? Foil them out. The first two are pretty easy, vanilla. You go ahead and foil these out. And I'll give you a moment to do that. Please raise your hand when you've successfully foiled so I know where we are and we can move on. Thank you. Have you foiled? No, but there's more blanks in the back. There's more homeworks in the back. Or in your backpack, that'll work too. What did you get, those of you who successfully foiled? Okay. I submit for your consideration that this right here, this weirdness, is also a FOIL problem. And I know you know how to FOIL because we just FOILed. What does the F in FOIL stand for? It's classroom appropriate. No. First, the first terms, right? What are the first terms that we're multiplying in this part? What are the first terms? X and x, which makes x squared. See, that was easy. What does the O stand for in FOIL? The outer terms. So let's look at those. This is where it gets a little bit weird. I have an x here. This is my outer term on this side. The outer term here is the 1 minus 2i and its negative sign. So to do the O, we're multiplying the outer terms. What's the sign going to be when I do that product? This one's positive. This one's negative. So what's it going to be? Negative. And it's going to be x times the 1 minus 2i. We're just going to smush those together for right now, right? X times 1 minus 2i. We'll handle the math in a minute. Right now we're just smushing them. What does the I stand for in FOIL? The inside terms, right? The inner. So this is the inside term here. This is the inside term here. This one's negative. This one's positive. So we're going to multiply. That'll be negative. And then it's x times the 1 plus 2i. We're just going to smush them. We're not actually doing the math. We're just setting it up. Okay. And then what does the L stand for? The last terms. So let's be sure we're clear about what those are. It's this times F. So when I multiply those together, what is the sign going to be? Positive, right? Because it's a negative times a negative, so that's a plus. Okay. And I'm not actually doing the math yet, remember, I'm just smushing. So I'm doing 1 plus 2i times 1 minus 2i. Haven't really done any math yet, just set it up, but you survived, right? That was just FOIL. You know how to do FOIL. So now we need to think about some ways. This we're just leaving on ice for a second. This x squared plus 2x plus 1, we're not thinking about that. We need to think about some ways to simplify this stuff. And I want you to start by looking right here. 1 plus 2i times 1 minus 2i. We talked about that specific circumstance yesterday. Do you remember which part of our notes that was? What do you remember? Or you just remember that they were there? Yeah, it's the a squared plus the b squared, right? I'm going to tell you the shortcut, but then I'm also going to tell you why the shortcut works. I'm sort of taking another tangent here, okay? The shortcut is a squared plus b squared. Where a is 1, b is just the 2 value, okay? Remember, not the positive or negative, and not the I, just whatever's in front of the I. And 1 squared plus 2 squared is 5. This is the shortcut we learned yesterday, okay? You don't have to remember the shortcut if you don't want to. It does save a lot of time. If you don't want to remember the shortcut because you have enough in your life that you have to remember already, you could just FOIL. Here's what foiling that looks like. 1 squared, which is 1. Your outside terms, your inside terms, your last terms. What do you notice cancels out right there? The middles. And what do we also know about I squared? It's negative 1. That's positive 4. That's 5. Okay? If you don't want to remember the a squared plus b squared, you can just FOIL every time. Is there any I here? Is there an I? The I's gone, right? That is why you have to have conjugate pairs, Because when you go multiply that stuff back together, the I needs to drop out because you want something that looks like this with no i's anywhere. Hence why all your problems say with real coefficients. That was the longest tangent ever in the history of today. All right. So the short thing part of that story is that this is 5. So now let's look at some other stuff. What else, what other math do you see that I could do in there? I'm looking for a magic word. It's not please. In here, there's some other things I can do. I will add, but even before that, I will be canceling. What else do you see? That will move the math forward. Starts with a D. Distribute. Yes. Okay. I can distribute. See this negative x right here? Distribute, distribute. What is negative x times 1? Negative x. Very good, class. What is negative x times negative 2i? Positive 2ix, right? Smush them. Do you see any other distributives? Yes, right here. Distribute, distribute. Negative x minus 2ix. We have this 5 over here, and then we have this x squared. Give me some other math I can do now. What, Cassie? What did you say? You said what? But what did you say? I can combine like terms. These combine to negative 2x. I heard Paulina say cancel. What cancels? The 2ix's. Look, do you see any i's there? No. You may or may not be pleased to know that we're not doing that. We are done. It's not actually the final answer to the problem. You should either distribute all those through or do box method on this or whatever you like. But I know you can do that, and I'm not interested in spending class time doing that. But however, if you want to know the answer, where can you find the key? In the back and Google Classroom, okay? Take a few minutes to just sort of talk and rest your brain. We have not started the lesson yet. So just take a brain break while I pass out the notes. The reason why I had you read number 5 is because the problems can get kind of long, and you will forget to go grab the zeros from your synthetic division steps and put them in at the end. So you need to check that your zeros match your degree. So for example, if this is our second problem in the notes, okay? When we get through the whole problem, we should have how many zeros? 5, exactly. All right, so keep that in the back of your head. She just knew the answer. It was very good. It's a strong answer. So this is a review problem. Just to go over the method, there won't be any i's in your answer. It's just to remember the steps. So let's see. Juan, please read step 1 to us. Yes. Step 1. Yeah, and the symbol too. Read the little. Over the Q. Yep. Thank you. So that's our first step here. Which piece of this polynomial is the P part? Which number? Which is the P? The 4. Speaking of P, I told you I got a puppy, right? I showed you a picture yesterday. I learned this morning that you should not take the puppy out of the crate until you've already made your coffee. Bless you. Bless you. Because as soon as he comes out of the crate, he's going to pee everywhere. So you have to pour your coffee and then take him outside. By the way, it was black coffee. I didn't have to put cream and sugar. And the time it took me to pour black coffee, he peed twice. So now I know. So that's about P. Which part of these is the Q? Bless you. Which part is for Q? The A value, right? My puppy did not Q anywhere while I was pouring my coffee. So P over Q looks like this. Squiggly wiggly. What are the factors of P? Perfect, thank you. What are the factors of the Q? So I don't know, but if you had like a quiz coming up, I don't know, like Thursday, and there was a question that said list all the possible zeros, and you gave me just this, that is wrong. That's not correct. That's just the setup, okay? You have to now write all the different combinations of the numerators with the denominators. So that looks like this. 1 over 1, 2 over 1, 4 over 1, right? That's all the numerators matched with just the 1 in the denominator. And then you take all the numerators and match it with the 3 from the denominator. So that would be 1/3, 2/3, 2/3, 4/3. And then, if you were taking a quiz, like, I don't know, maybe on Thursday, and it asked you to state how many possible zeros there are, and you said 6, you'd be wrong. Looks like 6. But why is it not 6? Because it's plus or minus. So how many possible zeros are there? 12. Okay, 12. So be sure that you are paying attention to that if you have a quiz, I don't know, like maybe on Thursday. Han, please read step 2 for us. Thank you so much. If you remember from last unit, we had some mental shortcuts for 1 and -1 before you actually spend your time doing synthetic division. Here's the mental shortcut for 1. Add up all the coefficients in your head. If they equal 0, then 1 will work. So here's how that looks. 3 and -1 is 2. -8 is -6. +2 is -4. -4 is 0. So that means 1 will work. So please do synthetic division with 1. Is this missing any x terms? No. So you don't have to put any zeros. So go ahead and do your synthetic division. I'll do mine. And then we'll regroup momentarily. If you're not getting 0, you are wrong. And you've gone rogue somewhere and you need to figure it out. Everyone good? Okay. Now, this synthetic division got us to 4 terms. And anytime you get down to 4, you want to check if you can do factor by grouping. You actually can. Okay? So we're going to do factor by grouping next. If you could not do factor by grouping, you would just try another round of synthetic division. All right? But because this will factor by grouping, step 3 is not needed. Hayden, what does step 3 say, please? As necessary, but we don't have to because we can factor next. So Julie, please read step 4 for us. Thank you. So finish factoring, use those factors to find 0. So if grouping will work and I need to add the x's back in, what degree will I start with? 3, right? Because the original problem was 4, so I'm starting with 3. Take a minute and do factor by grouping on that, please. Okay, after factor by grouping, from that step only, you should have 3x plus 2 and x squared minus 2. Good? Right? However, I'm missing a factor. Where will that factor come from? The synthetic division step, right? This right here. Makes a factor of x minus 1. So then that's my factors. That's factored form. I need to use them for zeros. Now, if you have been doing insider's lie, that works only for specific circumstances, which happen to be linear with no a value, right? Because that would make this 1, and that's easy. But for everything else, you have to think a little bit more. So what you're going to do is take your factors, you're going to set them equal to 0, and then solve for the x. So this becomes negative 2/3. The one in the middle will have two solutions, right? Because it's quadratic. So I do what here to begin? Add 2, move the 2 over. Square root both sides. And what are you not going to forget that everyone forgot on their factoring assessment, and so therefore they all made 20s, plus or minus, right? 20 was like the average on that, or the most common thing. So plus or minus square root of 2. So far, here's all the zeros I have. I have negative 2/3. I have positive rad 2, negative rad 2, 1. Kat, please read step 5 to us. Thank you. How many zeros do I have, class? 4. What was the degree? 4. So I'm good? All right. Probably. I know. Oh, yeah, that's true, because mine, I changed my notes after I did them. All right, so I want you to get started on the problem on the back. I'm going to give you a few minutes, and then there's something I need to talk to you about, and then I'll give you a hint and leave you alone again, and it's like a dance. So I want you to just take a minute, and I'm going to leave the steps up here so you don't have to flip back and forth. So here are the steps. One. Did 1 work for you? No. Did anybody try the mental shortcut for 1? Right? That was good, right? It saves you some synthetic division. Let me show you the mental shortcut for -1, okay? The shortcut is this. You change the sign for the odd degrees. So if I wanted to do the mental, now I'm going to write it up here, but if I was just to show you. See how this is x to the 5th? Instead of using 1 for the mental shortcut, we're going to change the sign for -1. This one has an even degree, so we keep that sign. This one has an odd degree, so we change the sign. This one has even, so we keep it. And this one's just 12. So here's what happens when you add all of those. This is -4, -7, -12, 0. So -1 will work, all right? Again, you don't have to remember those shortcuts, but I'm showing them to you to save you some time if you can handle it, okay? So -1 will work. And then, is it missing any any x's? Yes. So there, single x is missing, so you want to do a 0 there for a placeholder. Not stupid. So there's my first round of synthetic division. Does anybody need a second to catch up before I start talking some more? I guess you're talking about my puppy again. No, I won't do that. How come I can't start grouping now like I did in the last problem? It's not 4 terms, right? How many terms are there? How many coefficients? 5. You couldn't do, we don't even have any factoring methods for 5 things. So what we need to do is step 3, another round of synthetic division. Would you like me to just tell you a number that works? 2. Oh, sorry. Pretend you didn't hear me. 2 works. Shh, don't tell that. So we do need to do step 3. But here's the thing. It won't do you any good to do your second round of synthetic division on the original problem, because you'll just end up in a similar spot where you have 5 things. So what you do is synthetic division on this new set of coefficients, all right? So take a minute and do synthetic division with 2 using 1, -4, 7, -12. Take a moment and do that. No more productive struggle for you guys. That's a thing, actually. Like, that's a term in the teacher world. All right, 1, 2, -2, -4, 3, 6, -6, -12, 0. How do I know I can do grouping right here? 4 terms, so let's do it. Oh, well, here's how you figure out what degree to start with. This first round of synthetic division is 1 degree less than the beginning, so this one is x to the 4. The second round of synthetic division is 1 degree less than that. It's x cubed. Okay, so here's step 4 where I do my factoring. So I've got x cubed minus 2x squared plus 3x minus 6. Oh my gosh, we're so short on time. Okay, math. X squared times x minus 2 plus 3 times x minus 2. Am I going too fast? Okay. And then they have an x minus 2 in common, leaving me x squared plus 3. I'm missing some factors. Where shall I get them from? The previous synthetic divisions. This 2, bless you, gives me x minus 2 as a factor. What was the first round of synthetic division? X plus 1. So this one gives me a 0 of 2. This one 2, this one -1. By the way, what's up with that 2? That's a what? It occurs twice, so it will bounce if we're graphing, but it's a double root, right? And then solving this one, set it equal to 0, gives you x squared equals -3. When you square root both sides, not only is it plus or minus, how do you handle the square root of a negative? I comes out front. So you have plus I rad 3, negative I rad 3, 2 2's, and a -1. That is 5 zeros.